Hello everyone. Today I'm going to be doing the continuation of the 3-unit paper and starting off from question 3. Right, let me write down the question first. So it's asking me to find, or rather state, that the zero of this function that I'm writing right now lies between 0.7 and 0.9. Okay, so 0.7 and 0.9. So that's what I need to show. Okay, to show that there is a zero, what you need to do is I need to take the function value of these two. So it's going to be 0.7 squared. So remember that taking the function is simply a matter of subbing it in, and ln of 1.7, and then taking again the function of 0.9. It's going to be 0.9 squared minus ln of 1.9. Okay, what's important is that this value over here, I managed to get minus 0.04, which is less than 0, and then the second value I got it to be 0.168, which is greater than 0. Okay, so I'm not sure if you heard of this technical term, but it's called by the intermediate value theorem. So let me write this down: intermediate value theorem. There is a zero between zero between 0.7 and 0.9. Okay, all right. So yeah, that's the actual theorem that states that you should have a zero as long as this is continuous. Okay, all right. So that's all you had to do. Show that one was negative, one was positive. Right, those two. All right. Now part two of this is saying, using halving the interval theory, find another approximation correct to one decimal place. Right, the one decimal place is really important. Now we go 0.7 up here and 0.9. What we're going to do is we're going to use g of 0.8, and I end up getting when I get 0.8 squared minus ln of 1.8, this turns out to be 0.05. Right, but now the thing is, okay, so what this is going to tell me, so because this is positive, right, because that's positive, what this is telling me is that my zero lies between 0.8 and 0.7. okay, but still I can't, you can't just choose 0.7 or 0.8 just simply because one value is close to the other. You can't do that. What I need to do is use halve the value theorem one more time. Okay, so this thing that I did showed me that it's between 0.7 and 0.8. Right, now I'm using 0.75 to even refine it even more. So taking 0.75 squared minus ln of 1.75, I get this to be equal to 0.002, which is again greater than 0. Now I know that my value is between 0.75 and 0.7. Okay, so if I know that it's between 0.75 and 0.7, so it's somewhere between 0.7 to 0.75, then rounding it to one decimal place, it's going to be 0.7. Okay, remember it's not at 0.7, it's not at 0.7, and it's not at it's not 0.75, and it's not at 0.7. I round it down to 0.7 for one decimal place. Okay, so that is my answer. Okay, part B. Part B of the question. Oops, sorry. Part B of this question is asking me to show this sine of 5x plus 4x plus sine 5x minus 4x is equal to 2 sine 5x cos 4x. Okay, now this is a simple, you just need to do the left hand side equals right hand side. So the left hand side, expanding it out, sine of a plus b, sine of a plus b, you end up getting sine of 5x cos 4x. Now remember, the sign expansion, you leave the sign the same, right? The plus or negative sign, you leave it the same. So in this case, it's going to become plus, but this time cos 5x sine 4x. And then the next one, I have a plus of sine 5x 4x, sine 5x cos 4x minus cos 5x sine 4x. Okay, so if you can see, these two terms are going to cancel out. Right, what we're going to end up with is just these two, which is equal to 2 sine 5x cos 4x, which is equal to the right hand side. Okay, that's it. Okay, part 2 of this question is asking me to integrate. Sine 5x cos 4x. Of course, don't forget the dx. Okay, now to integrate this, because it said hence, I need to use this result, right? Now it's not exactly the same result, so I'm going to introduce a 2 in there, right, to make it the same. But if I introduce, I need to get rid of it, so I'm going to have it in front of it. Okay, so we differentiated. So we didn't differentiate. So this is, instead of writing what we have inside here, I'm going to write half integral of sine 5x plus 4x, which is sine 9x, plus sine x dx. Right, now this one is using a standard integral table. You can do it straight away, but what we're going to end up with is, for the first term, it'll be 1 on 9 cos 9x. But remember, with when I differentiate cos, I get negative sign, so this must be a negative. And then the next one is just negative cos x plus c. Okay, now I guess you can simplify this a bit more, going minus 1 on 18 minus half cos, minus 1 on 18 cos 9x minus half cos x, right, plus c. Alright, okay, part C. It's asking me to do, using first principles, I need to differentiate f of x equals x squared plus 5x. Okay, the key is use first principles. So I'll write it down. So I need to use this limit of h approaching 0, f of x plus h minus f of x divided by h. Okay, now the key thing when we're doing these things, okay, I'll go step by step. I'm jumping a bit here. So subbing everything in, limit of h approaching 0. Remember, with x plus h, I'm replacing all the x's with x plus h. Right? This means when I replace x with x plus h, this gets squared over here, and then I go plus 5 times, instead of writing x, you write x plus h. That's the idea behind this. And then minus f of x, so it's going to be minus x squared minus 5x. Alright, so this part is just the original function, but minus of it, all divided by h. Now what I was trying to tell you before was, with these type of questions where you need to use the limits, and there's a h underneath, the idea is to do, as much as possible, difference of squares. Okay, so difference of squares, difference of cubes in these questions are going to appear quite frequently. Alright, so if you can see these two that I've underlined, that's the difference of squares, right? So I can rewrite this to go limit of h approaching 0. Remember how it goes, a plus b times a minus b. Right, so I'm going to write the a minus b term first, so it will be x plus h minus x multiplied by x plus h plus x, and then I have this term plus 5x, okay, running out of room, plus 5x plus 5h minus 5x all divided by h. Alright, let me cancel out all the terms that I need to. Right, the x, these x's disappear, the 5x and the 5x disappear, sorry, yep, that's right, 5x and 5x disappear, and all I have is 5h up there. Okay, right, so now see how I have h multiplied by all of that and h multiplied by 5 over here, right? So what I can do is, it's going to become limit of h approaching 0, h times 2x plus h, because remember inside the brackets this thing becomes 2x plus h, plus 5h divided by h, right? This h can be cancelled out with these two. Right? Because if I take this out, if I take this h out and then divide it, it's the same thing. Now once I take the limit, I will end up with, so putting h equals 0, I end up with 2x plus 5. Right? And as expected, that's what you get, right? That's what you get from here. Right? Okay, final question. Alright, is circle geometry. Let me draw this out as much as possibly I could. It's going to be a bad circle, but that's okay. Okay, that's the best possible circle I can draw. All right, and I have two chords. One starting from there, going there, and the second chord going from there to there. But remember, the center, it's not at the center, it's over here. Oh, I know it's given that that's 4, this is x, right? And the length of CD, is 7, right? So the entire, sorry, it's not 7, this is L, my mistake, it's L. The entire length of AB, on the other hand, is 7, right, which makes this bit 3. Alright, now if you remember your theorems about circle geometry, it'll tell you that okay, let's call this, going to be called E. It'll tell you that AE times EB is equal to CE times ED, right? Okay, so that's one of the theorems in circle geometry. When two chords intersect, that's what you get, right? So AE is 4 and EB is 3, so we get 12. And then CE is X. Now ED is going to be L minus X, right? It's simply L, my entire length, minus X. So I have this equation 12 is equal to Lx minus x squared. Taking everything onto one side, I get x squared is equal to, x squared minus Lx plus 12 is equal to 0. Okay, now the last bit of that, so sorry, I should have mentioned that this was actually the first part of the question. I needed to show this. Alright, okay, now that I have that, now that I have this equation, x squared minus Lx plus 12 equals 0, the next part of the question is asking, find the length of the shortest chord that passes through E. Okay, so part 2 is asking you to find the shortest chord. Now, the really naive way would be to actually jump in and differentiate this thing. Okay, that is not what we're going to do, not straight away at least, because you need to realize that in this circle, if I change the chord, even the length changes. So the length is not a constant, so you need to realize that. Okay, so that was a bad circle, but you get the idea. So what I need to do is make L the subject of this. All right, so changing things around, I get Lx is equal to x squared plus 12. Therefore L is equal to x, dividing by x, I get plus x plus 12 on x, right? Now what I need to find is the minimum L. The minimum L is what they're asking you for. So now I simply go differentiate dl with respect to dx. Okay, so now you can do this, and I will end up getting 1. So when I differentiate that, remember that's x to the power of 1 minus 1. All right, don't try to use the quotient rule because the top is just a constant. Just think of this as 12 to the power of 12 times x to the power of minus 1. So I end up getting minus 12 on x squared. All right, and I set this equal to 0 for stationary points. So the solution that I'm going to get from that is x squared is equal to 12, or x is equal to plus or minus, so sorry, x is simply going to be equal to square root of 12. Why didn't I take the minus root? Because x is a length, it can't be negative, right? And simplifying this, remember that's 4 times 3, I get 2 root 3. Okay, alright, so that's still a stationary point. I need to find the nature of it. So for that, I'm going to do the second derivative. It's probably not a good idea to do a table over here because it's really easy to get the second derivative, right? That's why I'm saying don't use the table, but some of you might disagree. So anyway, differentiating that, the 1 disappears, so that's gone. Differentiating this part, remember it's x to the power of minus 2, I will end up getting 24 on x cubed. Right? So when I substitute this thing in at x equals 2 root 3, L double dash, I don't know what it is, but it's going to be greater than 0. Okay, which means i.e. a minimum. Okay, so this is going to be my minimum, and remember it's not x that we're after L, and we just need to sub it back into the original one. So at L is going to be equal to 2 root 3 plus 12 divided by, now instead of writing 2 root 3, I'm going to write square root of 12. Okay, so I'm going to end up with square root of 12 up there, right? So cancelling out, I get square root of 12. So the final answer will be 4 root 3, and I'll get you to check that for me. Okay, that's it for question 3. If you have any questions, let me know, and thanks for watching.